Okay, class, this is our Unit 7 review. I've already worked it, and I'm just going to kind of go through so you can check your answers, and then any questions that you got wrong or may have guessed on, I want you to watch watch me explain it, maybe pause, and all of my work is in here, so you can kind of look at my work to make sure you know what to do, for instance, if you were to see these questions again on a test. Okay, now if you check you got the right answer, you know how to do it, you can go ahead and fast forward to the next one, but only do that if you know how to get the right answer. If not, this video is going to be brief, so just pay attention and listen to me explain how to work it. Okay, parent signature, remember I printed off your grade sheets today, and if you get that signed and brought back to me tomorrow, it will be worth extra credit on your test. Okay, so this first question, this was tricky for some of you. Okay, I saw this as a triangle right here. So let's see, I did my triangle, base times height divided by 2. This 18.1 was the base, or I used it as the base, could have been the height. And then this 9.3, oh, I'm sorry, goodness. 18.1, I was looking at that other figure. This triangle, base 18.1, height 9 divided by 2. I think my work is in there for that one, and I got 81.45 for that triangle. Okay, now some of you broke this up into a rectangle and 2 triangles. I took it as one big trapezoid. Either way, we should have gotten the same answer. For the trapezoid, the base 1 plus base 2, here's one of your bases, 18.1. And then this bottom base is going to be 18.1, and then you have to add in this 4.3 and this 4.3. Okay, and that gave you 26.7. So you add up those bases. The height is 9.3, and then all of that divided by 2. My work is in here, and I kind of drew a line. I finished it down here, and I got finished it up there, 208.32 meters squared. When I added those two up, I got 289.77 meters squared. Notice I crossed off these numbers. They were there as distractors. On both of these, they were slant lengths, which you do not need this. That is not the height of any of these figures. Remember, the height is always straight up and down, not ever slanted like that. Okay? So that's question 1. Question 2, this is your answer, 706.5 feet. A truck's tire has a diameter of 3, so there's my picture I drew myself. There's its diameter of 3 feet. The approximate distance traveled by the vehicle for 75 complete revolutions. That just means, and we've talked about this, when a wheel goes and it goes around, and even though it moves this way, it's covering the entire outside of that circular wheel, which is the outside of a circle is the circumference. So that's the circumference, but we want it 75 times. So I found the circumference of this circle using my formula pi times diameter, 3.14 times 3, and got 9.42. Then I wanted that multiplied by 75 times because I'm going around this wheel 75 times, 75 revolutions. So 9.42 times 75 is 706.5. On any of these, just pause, and you can look at my work. If you got an answer wrong, don't just erase. Go back and see where you multiplied wrong or divided wrong or whatever. Okay, 3, the decorative clock for the hotel lobby, diameter is 7 feet. Here's my picture. The approximate area. Okay, area equals pi times the radius squared. Remember that radius squared means radius times the radius. So 3.14 times 3.5. If my diameter all the way across is 7, the radius halfway is 3.5. So 3.5 squared means 3.5 times 3.5. I got 12.25. Then I just take pi times that, so 3.14 times 12.25 gave me this big 38.465 feet squared. Okay. The first Death Star in the movie Star Wars has a diameter of 99.2 miles. If 1 mile is approximately 1.61 kilometers, hopefully in that sentence you thought WKU, miles to kilometers. We know that 1 mile is 1.61 kilometers. It tells us that right there. about how many kilometers, I'm looking for kilometers, that's where I put my X, are in 99.2 miles. Miles are up top. Cross, multiply, and divide. This one was awesome because 1 times X is just X, so all I had to do was 1.61 times 99.2, giving us 159.712 kilometers. Okay, here's a composite figure for us. Cindy's creating a mosaic tile floor that has the shape and measures shown below. Point C, this is important, that point C is the center of the partial circle. So that means that if I made this, and you can kind of see I sketched a big circle, that just means that this would be the middle. So this distance right here, halfway, this 10 yards, is the radius of what that circle is. That's why it says is the center. What's the total area? So I did this rectangle right here. There's rectangle, base times height, 21 times 9. Gave me 189. This triangle, got my formula. Base 10. This again was a distractor. That is not your height length, that's a slanted. This right here is your height, which I had to use this measurement from over here. This is 9. That means that this is also 9. Okay, yards. So base 10 times height 9, and then divided by 2 gave me 45. Okay, then to my quarter circle, this is 1/4 of a circle. Okay, so my formula for the area of a circle is pi times the radius squared, and if I just want fourth of that, I'm going to divide it into 4, divide by 4. Okay, again, we just talked about the radius was 10, so pi times 10 squared. Remember, squared means 10 times 10, which was 100. Divide by 4 here, and over here on that triangle, I use the trick that we learned in class where I can go ahead and take that and divide it. So I knew that 100 divided by 4 was 25. So I went ahead and crossed that off and got 25. And then all I had to do was 3.14 times 25. Same thing over here. When I had 10 times 9 divided by 2, I knew that 10 could be divided by 2, so I went ahead and crossed that off. And 10 divided by 2 is 5. Then all I had to do was 5 times 9. Okay? If you don't like that, you don't have to use it. It's just a shortcut that some people like. Okay, this one's kind of weird. Basically, I just want you to see that, well, hold on. The graph shows the relationship between a circle's radius and its circumference. So here's the radius down here. Here's the circumference. So in your table, go ahead and if you didn't, your radius, let's use 1, 2, 3, 4, and 5, what we have on our table. Now the radius times 2 equals the diameter. And mainly for circumference, we use diameter. Or we have that 2 times r, or 2 pi r, which is the diameter, but it's easier to do the diameter. So I went ahead and multiplied each of these radiuses by 2, so this was the diameter. Okay, the diameter would be 2, the diameter would be 4. Okay, so these are all represent diameters right here. Okay, then we have circumference equals pi times the diameter. So each of these, this is the diameter times pi, 3.14 times 2 gave us 6.28. 3.14 pi times the diameter 4 gave us 12.56. Pi 3.14 times 6 gave us 18.84. And times 8 times 10. Okay, ultimately what this is wanting you to do, here's the radius. When the radius is 1, you can see that over here if we come, it's not going to be even, but it's about 6.28 on our table. Okay? Mainly what I want you to remember is that when we have this right here, when we have circumference equals pi times the diameter, if I want this to equal pi, if I divide away the diameter on both sides, these cancel, so I have pi equals the circumference divided by diameter. Pi equals circumference divided by diameter. Okay, so, and we're going to see that again in a second. Okay, on this number 7, here's your answer, 161.29 centimeters. Hopefully you knew to set up a WKU on this one. Savannah noticed that 15 inches is equal to 38.1 centimeters. As soon as you see those things, I hope you're setting up WKUs. Inches and centimeters, 15 inches, 38.1 centimeters. Mrs. Garcia is 36.5 inches tall. Inches is on top, so 63.5 inches is on top. We want to know how many centimeters that is, so I have an X for centimeters and cross multiply and divide. Okay, there's my work if you're not sure how I got that. Okay, this kind of connects with number 6. During science class, Ansley was measuring the diameter and circumference of different glass beakers. She recorded her findings in a table. Find the ratio of every beaker's circumference to its diameter. So here's its diameter, here's its circumference. Again, we have that circumference equals pi multiplied by the diameter. This is going back to that string activity we did in class when we found that if you take the circumference and divide it up in chunks of the diameter, it leaves you with 3 and a little bit extra, or 3.14. Remember when we had our circle and we took that string and we laid it out around our circle and it fit 1, 2, 3 and a little bit extra, that 0.14 times around. That's meaning the circumference divided up by the diameter equals pi. So if we take our circumference and divide it by the diameter on each one of these, which I did here, circumference divided by diameter, you will get 3.14. Circumference divided by diameter, 3.14. If you didn't get the memo on this one, you should have changed this to 31.4. That was a typo. And circumference divided by diameter is 3.14. So just have this right here memorized. Alright, so I don't even know what family that is, wants to paint the deck around the swimming pool with the dimensions shown in the figure. What is the area of the deck in square feet? So this is their swimming pool, and then so this, all this is the deck around their pool, and they want to paint that, so we need to know the area. So the total area is the whole thing. It was a rectangle, base times height, 24 times 36. That was 864 feet square. Okay, then I had to find the area of the pool so I could subtract that out to know how much was the area of what was left. Okay, I broke it up into this. I drew lines here and here. And I did this rectangle, base times height, 12 times 30. 12 times 30. That gave me 360 square feet. And then I did these two rectangles, which were the same. Now here's how I did this. It told me that from here to here was 18. Okay, here to here was 18. So I knew of this from here to here was 12. 18 minus 12 was 6. So I had 6 inches, or I'm sorry, 6 feet left over, and I did 3 there, 3 there. Okay? So, and then this it told me was 24 feet. So this 3 times 24 was this rectangle, and 3 times 24 was this rectangle. So rectangle, base times height, 3 times 24, 72, and then we had 2 of those, so another 72. When I added up all of those pieces, I got 504, and that was the area of this whole pool right here. So I had to subtract that out from the area of the entire pool area, and I had 360 feet left over, square feet left over, that's the deck that goes around it. That's what they have to paint. Okay. This last one, basically they're painting this doorway that's a half of a circle, or this area I think. So this is a semicircle or half circle. My formula is pi times the radius squared. And since it's half of a circle, I take half of it or divide it by 2. Again here, and I don't know, maybe they were just meaning this inner part, but I made this my whole circle, and you can see that the distance going across is 8. I think it says square feet there, so we'll say that's 8 feet. So that's all the way across, that's the diameter, so half of that, the radius, is 4. Okay, so then I use my formula, pi times the radius 4 squared divided by 2. 4 squared again means 4 times 4, so 16. I did that little trick again. 16 divided by 2 is 8, so I went ahead and just canceled those out and put 8. And pi times 8, 3.14 times 8, gave me 25.12 feet squared. Okay? Hopefully that helped check your work and explain any that you were confused on. Don't forget to get that parent signature on your grade sheet so I can give you some extra credit. Thanks for watching.